Hello folks, this is Mungo Jerry. This is my first YouTube video. I just wanted to sort of quickly go over, make a supplementary video, so to speak, with debug, concerning debug, where you can actually program 32-bit with the standard DOS debug, uh, but but also to accompany that you need debug 32 to go with the standard debug, and I'll have in my information area where you can download debug 32 from. Anyway, I've already got this made up because I want to make this video as quick as possible since there's not much time. There's a 10-minute time limit. But right here I'm going to use the CPU ID instruction, and I'm using debug 32 with it imprinted to start with. But the only reason I'm using that for right now is to to get the opcodes that are listed over here. I want to get the opcodes to print out the instructions. And just to go over that real quickly, starting at 0100 address, we're exclusive OR in EAX, and that's just to make it 0 because the first function of the CPU ID is what I'm going to use as an example, and that happens to be 0. So 6633 C0 is exclusive OR EAX. 0FA2 is the opcode for CPU ID, and then the next 3 sets of instructions are copying the results from the CPU from calling CPU ID, that returns a 12 byte string, and the way you read the string is EBX, EDX, ECX in that order. So I'm copying EBX into memory location 0123, EDX into 0127, and ECX into 012B, and those are spaced 4 bytes apart, obviously, because you store the first 4 bytes, then the second one, the second 4 bytes, the third 4 bytes, for the total of 12 bytes. And then right after that, we've got the standard 16-bit assembly there, move AH40, that's write to file or device. BX is the file handle, and we're using 1 because we're going to write to the standard output device, and that happens to be the screen in this case. And then move CX, CX, you put in the total amount of bytes you want to write, and in this case it's 12, as we mentioned earlier. And then DX is the address of the string that you want to display, and that starts at 0123, address 0123 here. And then we call the MS-DOS function dispatcher int21 or int21, and then int20 is terminate process. And then, as you can see, starting at address 0123 is where we can start storing the 12 bytes. So obviously our total program is going to be 12C minus the 100, so it'll be about 2C bytes long. And I'll show you over here. We go to the other window here, and we'll start up debug. Oops, let me switch the screen here. Go to this window. Okay, and we'll type debug, and then I'm gonna redirect an input file, a script file, so that it automatically type in the debug commands without us having to do anything. And there we go. Okay, the key to doing the 32-bit programming is you just have to enter it in manually as shown here. And as you can see, the 0FA2 matches the CPU ID from the other screen, the 6633C0 for the exclusive OR, EAX, and on down the line, that's the move EBX, CDX, and ECX, or EBX, EDX, ECX into the appropriate respective memory locations that we mentioned earlier. And then the rest of it here, move AH40, move BX1, and such, so on. And then we put in our RCX, that brings up the CX register, and you put in the length of the program, and in this case it's 2F bytes, as I mentioned earlier. And then you put in the name, and I'm calling it CPU.com. We write it, it says it wrote 2F bytes, as we can see, and then you quit, and then we're back to our prompt again. Now, if I do a dir here, we can see CPU.com is 47 bytes, and that's 2F. And 47 is the decimal of 2F. So from that point, we'll now run the CPU.com and see what we come up with, and there we go. Authentic AMD. And that's just calling the first function. That's just a quick example to show you that you can use the standard 16-bit debug to write 32-bit programs. That's just a short example, but just to show you that it's possible. Okay, thanks a lot.